Welcome. I hope everyone is doing well today, and I'm really happy to have you with us in our discussion about fats and the impact that they have on clinical outcomes. This is John Bagnulo. I'm, the director of nutrition and research and development for nutritional medicinals. And it's great to be back with you here in a clinical discussion around one of the real primary components and an area of nutrition where principles are really important in terms of understanding them and applying them to a patient population. When we talk about fatty acids, I would have these as our four primary objectives today. Really, I want everyone to be able to explain the impact that various fatty acids have on human physiology and some of the critical components of membrane function. Recognize that fatty acids and certain imbalances with respect to those fatty acids can significantly increase our risk for chronic disease and can influence clinical outcomes significantly. Identify the key food sources of each of these, and then understand how cooking, temperature, food processing can alter these fatty acids and the role that they play. So with those objectives in mind, we're going to dive in here. We've got a lot to cover, and it's a complex topic. So, I really want to get going on it. Really, the way we should assess the role of fatty acids and the need for certain fatty acids, we should look at under the biochemical lens, where if you look at the phospholipid bilayer, I think this is where we should start in this conversation. The phospholipid bilayer across all mammals, it has a fairly narrow physiological range of what's acceptable for different types of fatty acids in that bilayer, and that's because of the lipid raft, which certain fatty acids are more conducive or less conducive to the way protein channels in the lipid raft functions overall. So that's a really important part of the conversation today. Another obvious important, which many people are most interested in, is the role that fatty acids play in influencing inflammatory processes. And that being, of course, fatty acids are the building blocks for specific eicosanoids, which are hormones. And whether it's a thromboxane, a leukotriene, a prostaglandin, a prostacyclin, all of these eicosanoids, this family of hormones, have a major amount of control over things like platelet aggregation or forming clots, right? Bone resorption, many people aren't aware of that, blood pressure, and of course inflammation. So there will be a significant amount of time spent on that component of how fatty acids influence our health. And then it's important to appreciate that certain fatty acids are much more resistant to oxidation than others. And when those fatty acids are present in the mitochondrial membrane, it's a major determinant of the health of that mitochondria. The fatty acids that are generally entering our diet come from one of really 6 different places. The food sources we'll dive into, but it's noteworthy there are other lipids, lecithin and things along that nature, phospholipids that might be included in certain supplements and things like that, where they're going to contribute a very small amount of the overall lipid intake. But in general, across most human populations, fat intake ranges somewhere around 24 to 25% to about 50%. And we'll take a look at some of those percentages and what those ultimately mean and what's associated with different levels a little later on. We're going to start by talking about saturated fats, because that's the type of fat that we produce endogenously. That's the type of fat that we actually need the most of physiologically in our membranes. And you can look at the sources. You're familiar with those. I mean, you have the plant sources, which are coconuts, macadamia nuts, palm oil, and some other nuts to a lesser extent, and then obviously dairy and meat sources. And then the subclasses, I think short chain fatty acids are becoming more understood and appreciated because of how they're generated especially in a healthy microbiome. We know that, for instance, butyric acid or N-butyrate is, really essential for health and for optimal outcomes in our patients, and that it's very difficult to have enough of that butyric acid or N-butyrate without having a healthy gut. They're obviously produced when microbes act on fiber and resistant starches. Then you can see the medium chain triglycerides here, which are also very unique in the fact of, the way they're transported in the body, the way they're absorbed. They bypass some of the normal lymphatic pathway involved for longer chain fatty acids, but the sources of these are limited, right? I mean, they're primarily found in breast milk when we're infants, and they're found after that in only a couple foods. Would be coconut oil, or the fat from coconut, and the fat that's found in goat milk and goat milk products. But those medium chain triglycerides, as you can see, they're going to range from C6 to C10, and there's a great deal of information regarding the impact that those have on health and how important those are at certain stages of life, as well as in certain clinical conditions, neurodegenerative diseases and things along those lines. The medium chain triglycerides can be immensely beneficial to a patient. Now, the longer chain saturated fats, lauric, myristic, palmitic, stearic acid, again, those are found in both animal and plants. Stearic acid is found in nuts and predominantly in plants. Palmitic acid, which is 16 carbons long, is the type of fat that we tend to produce the most of when conditions are right and we have, lipogenesis, fatty acid synthesis taking place in our body. So that's the one we tend to have the highest levels of as a percentage of overall fats in our body. Unless something is really unique in terms of dietary exposure to certain types of, a certain type of fatty acid that a population might be consuming really large amounts of. It might be oleic acid, for instance, in a population that would be consuming massive amounts of olive oil as part of their regular diet. Then you might start to see that palmitic acid level be challenged by oleic acid. But typically, that's the fat that we have the greatest amount of in our body. It works really well in our lipid rafts. That's the good news. And then, to a lesser extent, in terms of its present, but a really noteworthy fat, is this heptadecanoic acid, which is an odd number. You can see almost all these are even number. All these saturated fats are an even number. But, C17, heptadecanoic acid, is really unique in terms of its protective effect on certain tissues in the body. For whatever reason, we know that higher levels of heptadecanoic acid are incredibly protective against stroke. If you look at the association of levels found in populations and their, looking at their risk for CVAs or strokes, it appears to be very protective, but it's only really found in certain types of fish. It's very unique in terms of where it's found. Dairy fat can be a very good source, but it's not widely distributed in food. Then, as I've mentioned, oleic acid, which is the predominant source of monounsaturated fat or subclass, is found in largely plants. It can be found in animal foods as well. It really is a function of what that animal is eating or grazing on. But for the most part, you've got 5 or 6 really rich sources of oleic acid, and those are listed. And we'll get into the nomenclature here in a moment, but it's I'm just trying to familiarize everybody here with your 3 major classes. I won't spend too much time on trans fats, because that's, even though some do occur naturally in the fermentation process and in the lower GI of a ruminant, trans fatty acids are really something that's more like new. I call them a new to nature molecule. They are present in certain fermented foods at very, very minute amounts, but even those are different than what would be produced synthetically in a processed food. So I'm really going to stick with saturated fats, monounsaturated fats, and then as we get into the polyunsaturated fats, these are the omega-6s, which, they can come from plants or animals. If an omega-6 fatty acid is coming from plants, it's going to be in the form of linoleic acid or gamma-linoleic acid for the most part. There might be some others that are, much more rare, unique, and those are coming from the types of oils that you see here, as well as nuts and seeds. I mean, linoleic acid, for instance, it's found, it's about 25% of the fat in something like a pecan or a Brazil nut, right? And in an almond, they may be at around 15 to 20% of the fatty acid content. So linoleic acid is widely distributed in nuts and seeds, as well as being found in oils and in industrial seed oils and things along those lines. Arachidonic acid is a fully formed omega-6. That means it's been elongated and it's been desaturated. So it's become much more polyunsaturated. So we have many more double bonds, and it's much longer. We'll take a look at that in a moment. And that's predominantly found in chicken and pork. Pork would be the leading source of that as an animal food. Omega-3 fats also come from plants and animals. If it's coming from a plant, it's going to be something like flax seeds, flaxseed meal, flaxseed oil. It could be found in smaller amounts in walnuts or walnut oil, but much smaller amounts than it would be found in flax seeds. It's also found in certain green leafy vegetables, such as purslane. So it is distributed. It's in Brazil nuts. It's in nuts and seeds and in certain plants, but in much smaller quantities than linoleic acid, and a much shorter list overall of reliable sources. Then when you get into your more elongated, highly polyunsaturated omega-3s, such as docosahexaenoic acid and icosapentaenoic acid, then you're going to be dealing with, for the most part, fish, oily fish in particular, but those can be found in eggs depending on what the chickens are exposed to in their diet. Chickens that are on pasture more, chickens that are fed flaxseed meal are going to have much higher levels of these, and that would also be the case for a grazing animal, whether that's beef or lamb. Really, the levels of these fully formed omega-3s are going to be a function of what those animals are grazing on, and more grass and less grain tends to produce a really favorable ratio with these. Now, this is what they look like molecularly. This is incredibly important when we talk about their influence on mitochondrial membrane health or on the lipid raft. You can see that as you count down from the terminal end, the first double bond occurs, and that is, here in the case of, you can see you got an omega-9 monounsaturated fat or oleic acid. We're counting in here from that terminal end, and you can see you've got linoleic, you've got alpha-linolenic. You can go all the way down to much more unique stearidonic, highly polyunsaturated omega-3. But these are all, again, the carboxyl end is at one end. You've got your first double bond, where the omega-3, so to speak, would refer to where the first double bond occurs in this chain. And then if it's monounsaturated fat, in the case of oleic acid, it has one double bond. It's an omega-9 because of where it occurs. If it's a polyunsaturated fat, it's got two or more double bonds. Omega-6s, again, that first double bond occurs, after that sixth carbon from the terminal end. And, it's the same with an omega-3. First double bond occurs after the third carbon from the terminal end, and so on. So this is how structures are aligned, how they're named. This gives you a look at what some others look like, and you can see that when you get down here into arachidonic acid, these are, in this case, you have 4 double bonds. You've got 5 double bonds with icosapentaenoic acid, and so on. And this is, again, this is really an oversimplification of how many polyunsaturated fats are actually present in a membrane, a phospholipid bilayer, or the cell membrane, so to speak. And you can see here where they are found in relationship to the types of eicosanoids that are produced, right? We produce eicosanoids as a primary family that controls inflammation and how we form clots and blood pressure, but there's also docosanoids that have an influence on certain facets of our health, and octadecanoids, which also can have an influence on things like circulation and cell function. But for the most part today, we're focusing on the central part of this slide when we talk about membrane fatty acids. But again, there are some very complex, highly polyunsaturated and elongated omega-3s and omega-6s that rarely get talked about, but they do play an important role in human health and in bilayer function. Where are the fats coming from, and how has that changed, over the past 60 years or so? I think it's really fascinating to look at this, and to look at, if we go back to like roughly 1960, you can see that, the levels of the levels of certain components of our food supply have risen dramatically. And you can see, for instance, soybean oil has had one of the largest overall increases. Pork has increased significantly as well. And you could point to those two as examples of where we are getting larger and larger amounts of either arachidonic acid in the case of pork, or more omega-6 fatty acids in the case of something like soybean oil. But the rise of vegetable oils has been profound since 1960, and certain animal, certain sources of animal protein have dropped due to population, public health messages, certain concerns that different populations have around the influence of fats on health, and some of those have been, I think, misunderstood. But back in 1957, the Ansel Keys study really, kind of set the tone, I guess, for the perception around saturated fat, around polyunsaturated fats. And at that point in time, if something raised our cholesterol levels, well, it was deemed unhealthy. And if something lowered our cholesterol levels, then it was deemed a good fit for human health. And we know now that it's not that simple. And in fact, it's in many cases, it's not true. So we'll take a look at that here in a little while as well. But this just shows you how things have changed. And it gives us, I think, a really good explanation for why physiologically we've seen tissue levels change in Americans and in North Americans, and why maybe we have, higher levels of certain chronic inflammatory conditions. So again, these are associations, but we are starting to get more and more research and clinical trials that do demonstrate higher levels of omega-6s in the diet, really contributing to more inflammation and more problems with oxidation of things like our LDLs. So it's significant. We've talked about vegetable oil and how much that's risen here, again, over the last 64 years. You're talking about roughly a twofold here, 2x increase. At the same time, saturated fat has decreased significantly. These are, the main, if you would take a look at this, is your main saturated fats, as I mentioned earlier, and butyric acid or N-butyrate being a short chain fatty acid. You can see where that is predominantly derived from. I will say butter is around 4% N-butyrate, 3 to 4% N-butyrate by weight. So that's by far the most significant or concentrated source in the diet. But you'll find some in things like whole milk yogurt, whole milk for that matter. But most of the N-butyrate in our body is going to be endogenously produced if things are good in the microbiome. And then we make our way through the medium chain triglycerides, as I mentioned, coconut milk, coconut oil, and you get down to some of these other ones that are found in meat and dairy. And we've talked about heptadecanoic acid, but that's just what they look like. And then you can see here that if you take a look at the major food sources of these, what they're predominantly made up of, you'll see that, for instance, meat, it's predominantly, as is the case with human physiology, it's mostly that palmitic acid, that type of saturated fat. And that when you get into cheese, you're going to have, varying levels of the other category towards the top. Same with meat. And those others are really a function of the types of fatty acids that the ruminant produces. And some of those fatty acids end up in the cheese or yogurt. Some actually end up in the meat. But again, whether it's cheese, the milk that the cheese is being made from, you can see here that you have varying levels of these. But by and large, they're fairly consistent. It's coconut that would be very unique in comparison to these. And that's what we're looking at here. You're looking at the fatty acids that are present, and you can see that you've got a very, very high level of those medium chain triglycerides, which again, really unique in terms of their ability to form ketones even in a non-fasting state, and that's why they're so therapeutic to certain neurological conditions. But in general, we are trying as a population, as a system, or certainly in medical school and nutrition curriculums, we're trying to shift away from the messaging that saturated fatty acids are contraindicated or harmful to cardiovascular health. And this is a paper by Astrep and some others in the Journal of American College of Cardiology. It's a 2020 paper, so it is 5 years old, almost 5 years now, and it really starts to highlight. I shouldn't say starts to highlight. It does highlight some of the important messages that need to change, whether that be in medical school, in cardiology curriculum, or even for kind of just mainstream public health messaging. That red meat, chocolate, whole fat dairy, these are complex foods. These are not they are not, they're unfortunately associated in the court of public opinion with cardiovascular disease, but that's increasingly being shown to be false narrative. So this is a great paper for those that still question the role of saturated fats in promoting health. Now, when we look at these three classes of saturated fats, the medium chain fatty acids are unique in terms of they just don't require the same level of emulsification. Bile is the amount of bile required is reduced, and their enterohepatic circulation is different. That's why if you take a look really at how they're absorbed across the brush border, how they can travel directly to the liver in the portal vein as opposed to the lymphatic system, you start to really understand the improved availability of this fatty acid to all of our organs, our muscles, into essential tissues rapidly and efficiently, as opposed to having to be packaged into chylomicrons, et cetera. So really unique. And I think that a lot of us are interested in this research and in future research as to how these medium chain triglycerides can help people in a wide variety of metabolic conditions. But I think it's a compelling argument to have these in our diet every day, whether that's from coconut oil or goat milk for that matter. I think that's less important, but I think there's a strong argument that medium chain triglycerides, if consumed on a daily basis, can really help people with neurological health, and especially in the aging process. Now, again, continue on with the theme of medium chain triglyceride metabolism. Unlike the long chain fatty acids, these MCTs do not need to be activated by carnitine, so they don't require that carnitine shuttle. They're good to enter and to be metabolized by the mitochondria. This is just, again, another example of an advantage over longer chain fatty acids when it comes to fatty acid metabolism, ketone production. Just metabolically, there's just a huge upside. And the amount that can be tolerated by an individual, well, again, that varies widely, but I think it's always good as clinicians to find, whenever possible, to find a way to incorporate these and to find that ideal physiologically acceptable amount for a patient based on their tolerance. And, you increase the amount slightly, but I think anytime you can get ketone production, especially in an older population with chronic disease, I think the upside is significant, and so it's worth the effort. So that's why I really wanted to make sure that I took a moment here to highlight these medium chain triglycerides, to really promote the positive influence that they have on human metabolism and overall health. And hopefully we'll have time for some questions at the end. We can dive into these. Again, they, in addition to having those types of favorable advantages, when we look at metabolism, caprylic acid, it's been shown to be anti-inflammatory and to block the effects of lipopolysaccharides on macrophages. So the anti-inflammatory effects are less appreciated, and the ability of caprylic acid to lower LDL levels is also it's not well appreciated. So all of this goes into a greater context of medium chain triglycerides and again, how it is we can incorporate them. And again, there are saturated fats. So that brings us back to a very pivotal conversation that this is probably the best time to have. Saturated fats, as I mentioned a moment ago, are the class of fats that we have the greatest overall window of physiological acceptability in a membrane. we can tolerate, in comparison to other types of fatty acids, we can tolerate the greatest amount of saturated fat in our diet and in their ultimate incorporation into our phospholipid bilayer, or our membranes, our cellular membranes. We can incorporate the greatest amount of saturated fats without it disrupting what we need for a level of function with that membrane, which is, again, what we call this lipid raft. You can see here in the center of this small section of the phospholipid bilayer, you can see the protein channel, and that protein channel has to make what we call conformational changes. That means the protein channel has to be able to change its shape slightly to transport molecules out of the cell and to bring nutrients and other molecules into the cell. So we call that a conformational change, because the protein, of course, is a chain of amino acids and other molecules that serves as a channel or a tunnel through the membrane. Well, it has to be able to change shape. And the reason that it can change shape is that the fatty acids on either side, or that where it's not two-dimensional, this would be three-dimensional, that the fatty acids and those phospholipids that are surrounding the channel, the types of fatty acids that those contain ultimately influence how much of a shape change can be made by that channel. So again, if that channel is wrapped with omega-6 and omega-3 fatty acids, may not have the integrity needed, it may not be able to make the correct type of conformational change. So the right mix of fatty acids in the cellular membrane or phospholipid bilayer is essential for lipid raft function and for those protein channels to be able to do their job efficiently. That's really important here. And you can see that the different shapes. If we look at these fatty acids under an electron microscope, you can see they have a wide variety of shapes. And those saturated fats, in the case of palmitic acid in the top left here, that straight, rigid chain can be packed together very tightly. That gives our cell membranes very good integrity. On the other hand, if you take a look at, again, your omega-3 and omega-6 fatty acids, they take up a lot of space, right? You've got ring structures here. You've got like a J-like structure with linoleic acid, and then with oleic acid, again, that's a monounsaturated fat. That's kind of the happy medium. It's a little, it's got a bend in it, but that's probably why it works really well in the membranes, because it's not as disruptive. It doesn't take up as much space as some of those omega-3s and omega-6s. So it's that happy medium that we also have a large amount of like physiological acceptability here in that membrane. So again, that lipid raft is an important part of this conversation. We start to build our cell membranes or phospholipid bilayers out of too many polyunsaturated fats. It can be disruptive. We need to have some, that's clear. We can tolerate a significant amount of monounsaturated fat. That also is really clear. And saturated fat, again, is the one that is incorporated the best into that membrane and also has the greatest resistance to oxidation. So that's another upside, and should really be put in that list of arguments for saturated fat in a healthy diet. So we talked a little bit about, the eicosanoids here earlier. Just a quick refresher. Eicosanoids of the series 1 variety can be mildly inflammatory, but it's usually not a big, those eicosanoids are not a huge influence on inflammation and platelet aggregation or blood pressure, but the series 2 are. So prostaglandins and thromboxanes that you see here, PGI2, TXA2, PGE2, those are all very pro-inflammatory. We're going to form those from arachidonic acid, as you can see on the slide. Arachidonic acid can either come from eating, let's just say, the dark meat of chicken, eating, pork fat, where the animals are predominantly being fed corn, soybean meal, right? Typical grain rations. It just makes its way up the food chain in terms of what we call bioaccumulation, and those animals will convert the linoleic acid found in the corn or the soybean meal. They will convert those omega-6 fats found in plants they'll elongate them, they'll polyunsaturate them, and create this 4 double bond, highly elongated arachidonic acid. Now, if we eat if we eat corn oil or sunflower oil or safflower oil, our body needs to perform that conversion, and it's not perfectly efficient. So there is always a limitation as to how much of those that we convert to arachidonic acid. But nonetheless, those omega-6s can come from plants or animals, but once they're in the form of arachidonic acid and they're stored in our cell membrane, when we're under stress, when we suffer an infection or an injury, cyclooxygenase as an enzyme, a stress type enzyme, is going to cleave that fatty acid out of the membrane, and it's going to be used to form this series 2 hormones. Now, on the flip side of that, we can also store eicosapentaenoic acid or docosapentaenoic acid in our membranes as omega-3s, and when we need help in terms of maintaining the right type of clot formation or preventing a clot, when we need to lower our blood pressure, when we need to have a balance and have less inflammation, we can cleave those fatty acids out of the membrane and produce series 3 eicosanoids that you see here that will promote vasodilation, that will inhibit bone resorption. Again, that's something that's not appreciated in this broader conversation. Prevent clots from forming, and that's, again, it's all about balance. So it's not as though we don't need the omega-6s. We do. We need omega-6s, and we need to have the inflammatory process available to us for survival. It's absolutely critical. But we need to have balance, and we can't have things tipped on their head where we have chronic inflammation because of an overload of omega-6s in our fatty acid profile, in our phospholipid bilayer. We can't have that. Otherwise, it invites chronic disease, and because of their polyunsaturated nature, it also invites greater levels of oxidative stress. So this is again a quick illustration that shows you how these eicosanoids form different series of molecules that either promote inflammation, vasoconstriction, or platelet aggregation. So I'm sure you're familiar with this on a variety of levels. We know that if you look at this is a great 3D graph that I really like, and it looks at tumor necrosis factor, R1 and R2, as they relate to where the energy is coming from. So you can see here, for instance, the lowest level of EPA and DHA, which is at 0.02 roughly as a percent of energy. You go to that back corner, if you get that level of EPA and DHA, and you get the highest level of linoleic acid from vegetable oils and things along those lines, again, soybean, sunflower oil, safflower oil, canola oil, all of those vegetable oil blends contribute large amounts of linoleic acid. If you get that type of profile here, you get your absolute highest level of tumor necrosis factor, which we know is a very, very significant marker indicative of inflammation. So again, different ways we can look at it, but you want to really minimize the percentage energy, that is coming from linoleic acid, and you want to try to make sure it's balanced, that you have, because you're going to see here at the very front of this, you get your lowest level of tumor necrosis factor when you have the most amount of omega-3s and you have your least amount of omega-6s. You can see here, you get your least amount of inflammation. And this has been, again, this is not new. This has been presented in a lot of different studies in different ways. So that omega index, which now we have available to our patients, right? It's a blood test that most labs, Quest, LabCorp, most labs offer the omega index, which is great. And you can see again, you're looking at like the last 3 months or so. That's typically how long these red blood cells last in circulation. You get a really good picture for where a patient's levels of omega-6s and omega-3s are, and it can really start to highlight why you might have some of the more pro-inflammatory effects going on, where some pro-resolving mediators are needed. So that's really good. This looks at neurological health, this study, and it's great. It's a great look at how omega-6 and omega-3s shape things like brain inflammation, not just cardiovascular risk. I talked about bone resorption. A lot of people aren't familiar with that, but you look at isoprostanes and the effect that they have on bone health. It's really clear. Vegetable oil compared to sunflower oil, real significant differences in terms of the amount of bone resorption that takes place. And again, it's whether you're looking at 6 months, 24 months, you find that the omega again, the omega-9, monounsaturated olive oil, not a great source of omega-3s, but doesn't contain as nearly as much omega-6s as the sunflower oil. So that's, the primary effects that you're going to see here on that particular area of health. Now, this slide is taken from the PURE study, which I think is really one of the landmark studies of all time, and it's amazing that it's 8 years old now. But if you're not familiar with the PURE study, it's in our references. It's free, available online. Remarkable paper that looked at fat consumption, carbohydrate consumption, protein consumption, different types of fatty acids, looked at levels in it, 55 or 56,000 participants, from 18 different countries over 5 continents. And again, look at these curves. You can see that as monounsaturated fat increases as a percentage of a population's overall energy, all-cause mortality goes down. And although it flattens out at the bottom, it is a very unique curve in nutritional epidemiology, given the fact that it doesn't start to turn up again. Polyunsaturated fats do have a sweet spot, somewhere around 5 to 6%. You can see that's where overall, you can see that hazard ratio bottoms out, right? So, you get a slightly under 1, slightly protective effect from having polyunsaturated fat around 5 or 6%. That starts to turn up again. So that speaks to what we were just talking about. At least in theory, that's not the object of this study. These are associations, but we'll go a little bit further here, and we'll look at the Harris papers, which are also excellent, looking at omega-3 fatty acids and all-cause mortality. Again, you can see that with EPA and DHA, you can see what those curves look like, and not so much with DHA, but with EPA, you can see that hazard ratio turns up a little bit, once you get to around the 50th quantile, you'd say, percentile. So again, there's a physiologically acceptable level even for those omega-3s. And this is from the James O'Keefe, Nicol Antonio paper in the journal Heart. This is about 7 years old. And, it's a great paper if you haven't seen it. And it really looks at the role that omega-6 fatty acids play in the oxidation of LDLs, and how, that's something that we know is, a big component to the etiology of heart disease. Oxidized LDLs. Why do LDLs become oxidized? Well, it just really depends on how susceptible they are to the different types of pro-oxidants in our blood. It could be high levels of iron in a person's or a patient's blood. It could be other things, but the linoleic acid is really vulnerable to oxidation, and that's the primary step here in heart disease. It's the oxidation of LDLs. And so this paper is a really good one to deepen your understanding of how omega-6s work against human health, but especially heart health, which again, they've been given that stamp of approval for a long time now because they lower cholesterol levels, but that's not really how we want to evaluate a food in terms of its influence on health or even heart disease. This gives us this is from the USDA nutrient data, and it shows you how much of EPA and DHA is found in some different portions of fish and seafood. So I think this is a really useful chart. It's one of the best ones out there. It's based on 3-ounce portions. You can see the levels vary widely, but there are some fish here I think that are really outstanding, and I think that are very cost effective as well for underserved populations. I think canned sardines, canned mackerel, canned salmon, I think that those are incredibly cost effective ways to help a population be better nourished in many ways, not just with respect to their omega-3s. And it makes really high quality seafood affordable, because we certainly know that the wild sockeye salmon is very expensive, and some of the populations we work with, might not be able to afford that. So that's a great chart to use as a resource. Again, I won't spend too much time on this, but again, it's just really looking at the plant-based, which is most of the monounsaturated fats in the average population's diet. It just shows you how much are going to be present here in any 100 grams of a food. You see avocados, for instance, there's 70% monounsaturated fat. So that's a good resource to look at percentages. Again, a little bit of a review here on the physiological qualities of those fatty acids in a slide, and you know that they do play a role. There's research showing that they are significant in terms of their influence on neurological health and in neurons, and that cholesterol is an incorporated, very, very essential part of, or lipid as well, that's incorporated in this membrane, plays a big role in Alzheimer's disease, and that the way that cholesterol is incorporated and trying to keep the omega-6s and omega-3s in that sweet spot physiologically is protective. This also goes back to the PURE study. You can see you can see whether it's major cardiovascular disease across the top, and you got total mortality across the top, then you got major cardiovascular disease, and the percentage of energy coming from different types of fatty acids. Total mortality, again, flattens out with respect to saturated fat. But if you look at total fat, it's a downward slope, meaning that as you approach, 50% of calories coming from fat, this ends at 45%, but you're still seeing at least modest to minimal returns in a relative risk reduction. Really outstanding. Again, 55 to 56,000 participants in this. So it's a major study in that way. Now I'm going to go back a year prior to the PURE study, and these are slides from the Grasgruber paper that was in Food and Nutrition Research in 2016. Looked at animal fat, animal protein, raised cholesterol. And we know that animal fat and animal protein raises cholesterol. That's what's clearly shown here. That's no mystery. But then, the authors go on to start looking at how that higher level of cholesterol influence something like blood pressure. And you can see that as cholesterol levels increased, especially in women, it was more significant in women than it was in men. As cholesterol levels, as they increased, blood pressure actually decreased. And you can look at all the different studies that you have in this particular paper, and you can meta-analysis, I should say, and then you look at the prevalence of raised cholesterol in actual cardiovascular disease mortality, and you can see that as cholesterol levels increased, that the amount of mortality from cardiovascular disease actually decreased. Again, this is very surprising for some people to see this. Animal fat and animal protein, right? We're going to put those two together. We're going to look at blood pressure. They go down. Now, again, the Pearson's correlation coefficient, which is used to describe the strength of relationship between two variables. This is not obviously cause and effect. That's not this type of paper. This is looking at the association between animal fat and animal protein, the amount consumed per capita, and the prevalence of hypertension, in this case women, across a variety of different populations in different countries. But you clearly see that as you approach that 1.0 value, then the two variables become what we call inseparable in statistics. So not a cause and effect, but an association that is much stronger than something like smoking and lung cancer, much stronger than that, which is a 0.72 or 0.73. So again, this is really compelling to question this notion that if a food raises your cholesterol levels, as the case with saturated fat or animal fat, that we should abstain from it. Well, that's, again, it's not necessarily leading populations in the right direction with respect to their health. You can see here, total fat, animal protein, and glucose levels, raised glucose levels, much better glycemic control is observed in populations with higher levels of animal fat and animal protein. And then you can see as you move through these, cardiovascular disease mortality in women with animal fat and animal protein. You can see percentage of energy coming from carbohydrates and alcohol, and increased blood pressure or hypertension. Again, same thing, carbohydrate, alcohol, very strong linear type relationship between that intake and cardiovascular disease. And as I make my way through these slides, I just want everyone to understand that the PURE study and other studies that have started to vindicate saturated fat, whether it be from coconuts or from animal protein, that they're not new. That these are going back to the PURE study, this Grasgruber paper from 2016, and you can see that Here's plant fat and prevalence of raised blood pressure. More plant fat in the diet, typically lower blood pressures in any population. And again, animal fat, plant fat, and in this case, you've got total fat and blood pressure. You have your steepest slope. So getting fat from both plant and animals, in this case, appears to be most beneficial, probably because of the role of the fully formed omega-3s that would be found in things like eggs and oily fish. But again, that is not for us to kind of sort out right now. It's just really trying to illustrate the association here, and that would also be extended to the fat that comes from whole milk dairy products. You can see here that total dairy, this is in trials, that you can see the medium intake in terms of grams. You get your highest intake of full fat dairy, you get your lowest hazard ratio. And when you control for calcium, it gets even lower. So obviously full fat dairy offers advantages to low fat and non-fat dairy. In this study, which was conducted in Australia, again, a large number of subjects, and this is in the 7,000 to 8,000 range of subjects that participated in this, but really clear that full fat dairy consumed in larger quantities than lower trials was protective and had a lower hazard ratio. So really speaks to some of those unique fatty acids found in dairy fat, found across all foods, and including a variety of foods in the diet is in general very protective here, especially when it comes to fatty acids and foods that offer unique fatty acids. So with that, let's again, always important to stop for a moment, take a deep breath, consider the whole patient, right? It's easy to become really myopic when we get into things like fatty acids and influences on certain areas of our physiology. But if you consider the whole patient and the needs, physiological needs of that patient, I think it lends itself to a broader appreciation of different fats, as well as how those fats are going to be processed or cooked. Again, saturated fats do not contain any double bonds. That, in essence, makes them highly resistant to oxidation, which is incredibly beneficial, right? I mean, those steps that drive oxidation are typically involved in most chronic diseases. So there's, a huge upside to saturated fats, especially in cooking. Cooking with coconut oil, or butter for that matter, a lot of upside, not just in the medium chain triglycerides that the coconut offer, or in the N-butyrate that the butter might contribute to a patient and to our health, but also in the fact that those fats at higher temperatures are not going to form harmful substances that we call lipid peroxides. Olive oil and other sources of monounsaturated fats are moderately resistant to significantly resistant. We'll have a slide in a moment that'll look at olive oil and how well it does perform in comparison to other oils. But some of that is difficult for us to assert all the changes simply to the fact that it has one double bond. Some of it is that olive oil is unique in the fact that it's minimally processed. You can get extra virgin olive oil that is simply mechanically pressed. That doesn't happen with most other fatty acids or oils. And so because it contains substances such as squalene and polyphenols, olive oil is protected in the cooking process. So there is some complexity to that as well. But monounsaturated fats are somewhat resistant to lipid peroxidation and oxidative, formation of oxidative byproducts. Polyunsaturated fats, as we already talked about, are the most susceptible, and that's one reason, among others, that you got to keep them, to a modest amount of a patient's overall fatty acid intake. These oxidized fatty acids, whether they are in our LDL, whether they're in the mitochondrial membrane or in one of our neurons, oxidized fatty acids are something we want to minimize because they tend to propagate additional oxidation. That means they cause a chain reaction, and they can cause all types of mutative effects inside a cell. So we want to minimize that. And this is what lipid oxidation looks like. We form some really harmful substances as both secondary and tertiary products. Those aldols, those are very harmful to health in different ways. So, we're trying to minimize this. And if you take a look at the composition, again, you want to cook at higher temperatures with things that have more of the saturated fat content. So, and those are really the 4 or 5 at the top. But I think coconut oil stands out and butter as well for many reasons. They've got advantages that some of those other oils with saturated fat don't, like lard or palm oil. And then you can see, the omega-6 and the omega-3 content in here as well. So this is from the USDA as well as databases in Sweden and Finland. So it's a good composition here that you're going to see. Next, we'll just take a look at what changes in olive oil compared to other oils at a temperature here. Again, it just depends on where you're looking on this, but you can see around at the smoke point, which is where that oil literally starts to burn and produce noticeable smoke. Here you've got a smoke point of around 206 degrees Celsius, and that's very hot in terms of Fahrenheit. Most people would never cook at that, but with extra virgin olive oil at high temperature, you can see you have the lowest amount of polar compounds, which is very beneficial to anybody consuming that oil. So here you've got the lowest amount of polar compounds, and you go down to canola oil, you have the absolute most. That means it's the least protected, when it's brought to higher temperatures. So again, this is, I think, a really telling chart that looks at the chemical and physical changes in a variety of different commercial oils through moderate heating. So this is for everybody to look at closely later on. Now I just want to give you some summary slides here before we dive into your questions. Again, saturated fats, are made up of a variety of subclasses, but those medium chain triglycerides offer very unique benefits neurologically and metabolically to our patients. They will raise, in some cases, saturated fats will raise total cholesterol as well as HDL levels. The good news is they tend to raise the size of our LDLs in addition to our HDL, so that's a win-win. You just have to be able to see past that rise in total cholesterol and understand that does not mean that heart health is going in the wrong direction. Again, these saturated fats promote lipid membrane stability and resistance to oxidative and oxidative stress processes. And they can be really compatible with physiological requirements, more so than most fatty acids. Monounsaturated fats also a really good fat to base a lot of our dietary fat intervention around. Again, at least moderately resistant to oxidation, very supportive of the lipid raft and its function. Really compatible overall with human physiology. And the good news about monounsaturated fat in the case of something like extra virgin olive oil, you can, at the same time you're getting that oil, you can really acquire some other very unique and beneficial substances in the way of polyphenols and some other molecules unique to that minimally processed oil. Polyunsaturated fats are the ones we got to look at a little more closely. We know that they really influence things like blood pressure and platelet aggregation and overall what we call hemodynamics, right? That big role in circulation, circulatory processes. Our non-alcoholic fatty liver disease patients or patients with fatty liver disease, you want to keep these to a really low level, especially the omega-6s, but really all polyunsaturated fats, because they're a little harder on the liver to process and metabolize. And there's definitely a U-shaped curve here with respect to all-cause mortality. So there's that sweet spot somewhere around 5 to 6% of energy. And I think that's probably a good slide to end on, because my hope is there'll be some great questions. We can have some discussion about this topic here for the next few minutes. So with that, thank you very much.
Great, thank you so much, Dr. Bagnulo. While everybody is, this is Laura Doherty. I'm the clinical manager over at Functional Formularies. So if you have questions for Dr. Bagnulo, please go ahead and type them in. I know we've gotten a few already. While we're waiting for questions, I do want to let everybody know that in the handout section, you can find a copy of the slides and all of the references. In addition, you will also get an email from us with the slides, references, and your CPE certificate from CDR. So with that being said, Dr. Bagnulo, are you ready for your first question?
Yeah, that'd be great. Thank you.
Are you at all familiar with algae oil for cooking, in algae oil coming from fermented plants?
I am very familiar with algae oil, but I'm not familiar with its use in cooking. I'm only familiar with algae oil and algae byproducts as a way to offer patients who either can't tolerate fish oil or krill oil, maybe that's due to like a seafood allergy, or they just want to get their their DHA strictly from plants in a marine plant in the case of algae, but I'm not familiar with it in the way of cooking, only for algae's use as a source of DHA.
Okay, thank you. Other than the Omega Index lab, is lab work from VLDL or small, large density labs still appropriate for heart health, in your opinion?
Yeah, I think that looking at an LDL pattern, which would reflect the average size of a patient's LDL molecule, typical LDL molecule, I think that's very valuable as part of an overall assessment. I think it would be one of the most important things to know about a patient is the percentage or amount of small, dense LDLs that they tend to have in circulation at the time of a blood draw, what their typical LDL pattern is it pattern A or pattern B? I think those are, again, two of the more valuable tests that one could have available to assess, their overall risk. And I know that sometimes those have to be, have to be worked towards, or sometimes there's, a little bit more of a hurdle to get those cleared for insurance purposes and things like that. In lieu of not having those, I think there's a lot of value for also comparing HDL levels to triglycerides. Lower triglycerides, higher HDLs is a very, very favorable. Again, having low triglycerides and a high HDL, having a very low ratio in terms of that comparison, has been shown in a variety of studies to be associated with a much, much lower risk for having any type of cardiovascular disease. So I would use that if you didn't have, the LDL particle size or the small, dense LDL population. You didn't have those numbers, then I would fall back on just looking at triglyceride to HDL ratio. I think a lot can be gained from comparing those two numbers.
Okay, thank you. There's a lot of questions in here, Dr. Bagnulo, about seed oil. So let's talk about that for a bit more. The first one is, could you speak on seed oils, and are these being viewed unfavorably mainly because of the processing or GMO origins rather than the fatty acid composition?
No, today's conversation was strictly based on the fatty acid composition. I'm not going into GMOs. I'm not going into anything other than the omega-6 content relative to omega-3, or just the absolute omega-6 content. I think that most of these seed oils, unfortunately, have very unfavorable levels of omega-6 fatty acids. And so it sets, with long-term consumption on a chronic basis, it sets a person's physiology up for more susceptibility to oxidation. And I think that is the most important takeaway from this conversation. I'm not going into those other areas at all. I think there are so many reasons to use something like olive oil or coconut oil for 99% of your culinary or fatty acid needs. And then I think, the rest being supplied by Whole Foods whenever possible tends to work out really well. So I'm only speaking today on the importance of understanding a seed oil's omega-6 content, and using that as the best way to assess how much you can tolerate in a patient or in your own diet.
Okay, great. I think that actually answered several of these seed oil questions that we had come in, so thank you for that.
Yeah.
Switching gears here, just what is the best oil to use for light frying or browning, in your opinion?
Yeah, well, light would be, again, something that would be under 300 degrees Fahrenheit. I'm going to use Fahrenheit. I apologize for those that, might be listening in Canada. I don't have the Celsius equivalent here, but if you're under 300 degrees Fahrenheit, you can use a variety of oils. You can use coconut oil, you can use olive oil really well, extra virgin olive oil, and you saw the slide there. And there's another study that showed olive oil, when held at 350 degrees Fahrenheit for over 12 hours, had absolutely minimal amounts of lipid peroxides and of some of those secondary and tertiary degradation products. So extra virgin olive oil will hold up really well I can say this with confidence, at 300 degrees or less. Coconut oil will hold up to 400 degrees or less. So again, they work really well. And I don't think you really need to cook food over 400. I think that's, I don't think those temperatures are necessary. So for light frying, sauteing, I would just use extra virgin olive oil.
Okay, thank you for answering that. Do you have time for one more? I know we're right at 1 o'clock, y'all.
Yeah, absolutely, no problem.
So in terms of omega-3 supplements in regards to oxidation storage, and I'm only asking this, Dr. Bagnulo, since we did talk about cooking a little bit. Pros and cons of taking omega-3 supplements if you don't like to get it through food, and the storage capacity of that.
Yeah, I think that there's some questions about the efficacy. How much does it actually work when we take fish oil as opposed to eating fish? Some of the meta-analyses that look at, 35, 40 different investigations on fish oil supplementation, at the end of the day, they really raise serious questions about how much, or if at all, fish oil capsules or supplements help us. I honestly would say, I don't have evidence from looking at those meta-analysis that fish oil really produces much change in things like all-cause mortality or in risk for cardiovascular disease. We do know that there are some papers that show that it inhibits platelet aggregation, that fish oil will, in essence, in the blood, for in terms of layman's terms here. So it does prevent clots from forming, and we know that that's going to help certain cardiovascular patients. But in terms of big picture, big study, meta-analysis type data, I don't have a lot of evidence that fish oil helps a population like eating fish does. So with that being said, I don't know if there's enough strength of evidence, in my opinion, to take fish oil regularly. And I would say that you'd probably, if you are going to take a fish oil capsule, I think that there's more evidence that you should take it less frequently, maybe just a couple times a week as opposed to every day. And that's for some people that sounds counterintuitive, but the research would suggest that some of the marginal to minimal benefits observed by taking fish oil are when it's taken at very small doses less frequently than when it's taken in larger doses. And so what I'm saying here is that there might be, and we talked about this in the presentation, you saw those U-shaped curves with omega-3s, especially the EPA curve there, that you take too much fish oil too frequently, too large of a dose, and it might start to change things in the membrane of our cells that takes our health in the wrong direction. And maybe that's why with some of the meta-analysis on fish oil, that's why you don't see the protective effect, that the modest effect with small doses might get washed out by those populations taking larger amounts more frequently. So I'd say if you're going to take fish oil or krill oil or any type of marine source of EPA or DHA, I'd take it, I'd take it just a couple times a week, and I'd take it in a moderate dose.
Awesome, thank you. And for the last one, because this has been asked, I just counted, Dr. Bagnulo, 12 times. So I think you covered it a little bit in the presentation, but just recapping, what about avocado oil? Why can't you use it in cooking, or when can you use it in cooking? And that is will be my final question for you.
Yeah, no, that's a great question, and it's one that I do receive quite frequently. And I don't think that avocado oil is bad per se. I just think that when you take a look at avocado oil, and anybody can do this, you just put a little avocado oil in a glass, and then you put a little olive oil in a glass, and you look at them together. And I'm talking about extra virgin olive oil that would be minimally processed. You're not going to find an avocado oil that has the same level of polyphenols and some of those same attributes that olive oil does. That doesn't mean it's bad. I just don't think it stacks up very well against extra virgin olive oil for that reason. But even more importantly, olive oil have slightly less to significantly less omega-6s, depending on the variety of olive, depending on the type of avocado that we're making the oil from. So avocado oil it does have a fairly high smoke point. It's up around 400 degrees, but it does have a high level of omega-6s in comparison to olive oil, not in comparison to the industrial seed oil. So it's definitely superior to those. And I think that if you have a certain recipe that calls for a more neutral flavor and you want to use avocado oil, I think it's fine. But I just think in day-to-day cooking, I think olive oil tends to serve our health and serve us a little better. But again, I don't think avocado oil is bad. I just don't think it's quite as good as olive oil.
All right, that was very well summarized. Thank you so much. So that is all the time we have today, everyone. I know we didn't get to everybody's questions, and I'm so very, very sorry. We had a lot, so hopefully we got to the majority of them. Again, thank you everyone for your time. Dr. Bagnulo, thank you for your time and all of your amazing knowledge. I know that topic can be very deep, and you did a great job taking it to some good science, but also some practicality. Again, by the end of the day today or early tomorrow, y'all should receive an email from us with your certificate, all the references, and the handouts from today's event. And if you ever have any feedback, please don't hesitate to reach out to us. Thanks, everybody. Have a good one.
Thank you, Laura. As always, I appreciate all your help with this in this presentation.
No, you're very welcome. You're amazing. Thank you so much.
Thanks.